So welcome to the session, Coding Video Game as a Hobby, possible and kind of easy with Java. The kind of easy is because it depends if you decide to do 2D or 3D. More about that later. Just so we're clear with everybody, today's goals are quite simple. We're going to quickly talk about Java in the world of video game. It's a little bit blurry. Can you see it all right? We had to change the resolution. Hopefully you can read right. So yeah, we are also going to show you the two main game engines. They're more like libraries, but it's a slight difference. So basically, you can use those two and show you the basics about. Just make it full screen. Yeah, I could probably do that. But the thing is, I'm going to switch between everything quite often. Anyway, for now, it's going to be full screen. So my name is Simon Bedard. I'm French Canadian. I've been working in France for the past 5-6 years, roughly. I didn't start the cam. Do you want to keep it like that? No, you are perfectly correct. I do want to show my face. Well, it's not a necessity, but yeah, the background is not that impressive. I'm sorry about that. So yes, I'm in Bedard, so you can see my face both places. I'm a software engineer, currently on break because of COVID and such. I've always been developing video games in my free time. I've more or less learned how to properly code in Java doing video games, which wasn't perhaps not the best idea, but that's how I did it, and I'm quite happy about it. You can find me under JavaCon Studio for serious stuff on YouTube or GitHub. Actually, all the code I'm going to show you, well, more or less all of the code I'm going to show you is available on my GitHub, and you can find me under simon.con for more silly stuff on Twitch and YouTube again. So, Minecraft, Walkthrough, Ingress, and Slate Aspire. You should know about at least one of them. They're all coded in Java, and they're the biggest one I could find. Basically, Minecraft, well, I don't think I need to present to you what Minecraft is. Walkthrough is actually a French MMORPG, which was quite big. Ingress is the ancestor of Pokemon Go. And Slate Aspire is a little card game that sold about 1.5 million. Is there a video? No, there is not. I'm going to show you code. I don't show you any video, and the slides are quite bare. I put most of my time on the code instead. By the way, for the questions, if you have any question, I have the chat right next to me. I'm kind of used to Twitch. I mean, is there currently anything visible? There should be. There should be. You should be able to see the slides.
Yeah, we can see the slides. Everything is fine.
All right.
I will whisper him.
All right. Sorry about that. So yeah, if you have any questions during the presentation, just ask them right away. I'm kind of used to Twitch, so I can easily read the chat while doing something else. So if you have any questions, I'm going to go quite fast because I have a lot of content to show you, but I'm going to try to answer as many questions as I can. Okay. Is there an archive where we can watch later? I'm going to share these slides right after. So I should continue. So it's far from the biggest language in the world of video game. There's a lot of reasons for that. First thing first, Java used to be quite slow, as most of you know. Before version 6, it wasn't exactly that powerful. And that was a huge issue because a lot of people still believe that Java is not powerful at all, which is completely false. It's not as efficient as C++. So when you need to create a big game like a Cyberpunk, for instance, want a big project, you still need to go with C++. So if you want to create a large project, I would not recommend Java. Let's be honest here. That being said, that's not what I'm going to show you today. I want to show you that it's feasible to use it for a hobby. It's possible to create a small and medium-sized project with Java in both 2D and 3D. And yeah, so technically, it's perfect for hobbies. If you just want to create video games and you know how to do Java, you're going to be able to do it quite easily. Most of the engines nowadays use the lightweight Java game library. We're not going to touch on that too much. I just need to explain to you the fact that it exists, the fact that it's very, very important. It's the basis of most Java game engine, as I told you. It's very, very low level. You usually use that for drivers. So you don't want to tell the graphic card how to do everything. You just want to tell the graphic card, draw me a cube. And so basically, the library is going to allow you to say, oh, yeah, I want a cube. And it's going to check, oh, yeah, so I have that graphic card. I want to draw a cube. So this is how I'm going to draw a cube. It's a little bit more complex than that, but that's the level we're at with the lightweight Java game library. This is what was used for Minecraft. So basically, Notch used that directly to create the whole thing. There was a lot of optimization, a lot of stuff. Minecraft used to be quite special in the sense that no engine could do what he needed them to do. So he created his own engine, more or less, using the lightweight Java game library. If you want to create a game, like a real game, or even just a tiny, tiny game, don't start by creating an engine. That's a terrible idea. A lot of people have made this mistake. If you want to see how it actually works, then sure, create an engine. It is very, very fascinating. You can also take an existing engine and see how they've done it. But yeah, this is the lightweight Java game library. It uses OpenGL and Vulkan. I'm not going to talk too much about that because it's quite complex. It also deals with audio. It deals with multi-threading. It does a lot of stuff for you. But if you want to, get even more lazy and actually create a game, you're going to need to use one of the engines. So 2D versus 3D. Technically, you can do both with the both engine I'm going to present you, namely LibGDX and JMonkey. The thing is, most of the 2D games are actually calculated like 3D game nowadays. Oh, I have to move that a little bit. This is Shovel Knight. I don't know if you can properly see it. I'm going to increase the size of that thing so you can see it. It's one of the best example of what I'm talking about here. Most of the times on something like Unity or really all of the engines, you're actually going to draw your 2D game using 3D space. And you're just going to set the camera in a way that you only see the game in 2D. As you can see, there's a couple of layers, but they're all placed in a 3D environment. This is how most games do it nowadays for optimization's sake. It's too long to explain right now, but just know that, yeah, you can most of the time do 2D on the 3D game engine because they need to have a UI, so you're actually able to display 2D stuff. And most of the time, and not all of the time, in the modern game engine, you're actually able to do 3D using 2D game engine. Is it a good idea? No, it's not. So this is why I'm going to show you two engines, both with their specialties. But yeah, it is feasible. Just because you can do it, you don't need to do it. Just a fair warning, 2D is way easier, but it's not 3D. So if you're fascinated about how 3D works, because I do believe it is quite fascinating, you should definitely go for 3D. If you just want to take something simple and have some fun with it, you should definitely go for 2D because it is way easier. I mean, it's one less dimension. Let's be honest here. So LibGDX, the one we're going to use for 2D games. It's free and open source. I wouldn't talk about it if it wasn't the case. The 1.0 was released in 2014. It's 6 years old, but the project has started in 2009. So it is quite old. It doesn't taste dust too much. They've changed versions a couple of times. But yeah, it was started by Mario Zekna to simplify phone game development. Basically, LibGDX, the strongest part is that it's multi-platform. So you can technically develop a game on Android, desktop, iOS, and it used to be feasible to do it in HTML. Now it's a little bit more complicated. But yeah, technically you only have one project and you can deal with all of that. You just wanted to be able to create a game for this phone on this computer because it's way easier to test. The last update on the site was 1 year ago, which is quite a while. But that being said, the GitHub was updated a few days ago. So the community is still very active. The last update when the Discord was 3 seconds ago. Let's be honest, I didn't check that. But you can go and check the LibGDX Discord. It is quite active. If you have any question, you can ask them there. They have a very, very good community. It's actually great when you have something you don't understand on the tutorial or anything, you can ask them. They are very, very friendly, but they're mostly on the Discord. They have created a few games with the engines. So this is one page, and this is the amount of page. So as you can see, I mean, it's been there for a while, but there's a couple of games that have been created with it. It is actually incredibly impressive what you can do with that engine. You can also check on itch.io, which is a site where you can actually sell game. It's like the indie Steam, if that makes any sense. And you have a couple of games. All of them were made using LibGDX. And this one, by the way, I didn't have the time to properly check, but it's open source. So that monster of a game with all of the networking and the Android compatibility and all of that is actually available for free. I don't know where's the, I don't think they have the right resolution. There's a GitHub link somewhere. Yeah, here it is. So basically you have access to all of the source code. So there is a lot of stuff available for LibGDX. it is a very, very active community. So yeah, don't be worried about going in a dead project. Even though it's quite old, it is still alive. This is the one that's been used for Slate Aspire and Ingress. So you actually have some big titles under that belt. And yeah, LibGDX is pretty darn good. And I'm going to show it to you. So to install LibGDX, it's quite simple. You just go on their page and you click on the big red button. Once you've clicked there, you're going to have a little thing. By the way, tell me if I'm going too fast, right? You're going to have something called gdxsetup.jar. That little thing is quite simple. It's going to allow you to give a name to your game, the package, the game class, which is basically going to be your main class. We're going to call that main, just so we're clear. You give it a path. In our case, we're going to go for test. I'm actually going to need to change a couple of things. We're going to call it main GCON, because why not? All right, we're going to call that GCON because why not? Okay. If you want to build with Android, you're going to need to have an Android SD key. They do not download it for you, so you actually need to get the Android Studio. We're not going to do that today. We're actually going to go super simple. Maybe let's go iOS 2, just so I can show you the concept. Destination, right? So you also can select a couple of extensions. If you stay there for a little while, you're going to see what they do. In that case, bullet is 3D collision and rigid dynamic bodies. Free type is for fonts, tool is for tools, controller allows you to use controllers. Box 2D is something I'm going to quickly show you. Allows you to do some simple gravity and such. 2D allows you to actually use the fact that you have control and gravity to make lights, AI, everything. Once you're decided, you just go generate. We're going to download everything you need. Hopefully, it's going to be quite fast. Yeah, it's going to be quite fast because I've already done everything. So we can go and check test 2. Okay. And now all you need to do, Ashley is, I've never used it actually. It's a lightweight entity framework. It's actually to use game object for logic. So I'm not going to talk about game object logic. That's a little bit too complex. But yeah, that's paradigm for game programmation that you can use with Ashley. So where's my Eclipse? So let's go example libgdx. So once you have your path, you just need to go existing Gradle project. Double click here. You get in the path they've given you. So in that case, it's going to be test 2. I'm going to say finish. Is it already downloaded? I don't think so. Yeah, it's right here. So you already have the whole project. Sometimes you're going to need to actually build it with Gradle. I don't need to because I've already done it. And as you can see, you have a couple of package here. Not package, excuse me, files. So you're going to have the core, the desktop, and the iOS because we decided to build the game for desktop and iOS. You're supposed to put all of your code in core. All of your code in core, and just put the as it's called platform-specific code in the platform folder. So in this case, desktop. If I go here, if I want to start the game on the desktop, I have a desktop launcher where I have my lightweight Java game library application configuration. I can create my game, launch the whole thing. But if I want to try to start it on iOS, I need to start it with this file. So everything is separated. If, for instance, you had the Android folder, you would have the Android manifest there, where you would need to deal with the access and stuff like that. So this is very, very good. This is a multi-platform engine, as I told you. So this is the way to actually properly divide all of the platform-specific content. So if we were to just start the desktop launcher, just to see how it works, I start that thing. And I have my game, okay? We're going to talk about that real soon. In our case, I've created a simple thing called a simple libgdx. It's not that big, let's be honest. It was just a few examples, so I could make my presentation easier. We have the same one. So this is the basic one, the one we've started. In our case, I've kind of cheated a little bit. I decided to go with Gradle to have some stuff. It's not the proper way to do it. So now everything is in core. It can also work using desktop. But yeah, for my examples, I've actually added the desktop in the core. You're not supposed to do that. Let me repeat. You're not supposed to do that. But yeah, using Gradle, I was able to just change the imports, as you can see right here. For those that have never used Gradle, don't be scared. It's not that complex. It's basically like Maven, more or less. So in our case, see, I should have my desktop and core. My desktop should be implementing my project core, so I could actually start the game. And I would have stuff like my backend for lightweight Java game library, platform native desktop, 2D platform native desktop, so I can do all of the imports properly. In my case, I've just copy paste all of that, so I could use all of that in the core, so it's easier for me to show it to you. So let's get the first example. By the way, I'm not going too fast. Am I clear enough? I hope so. So yeah, first thing first, when you create your project, you need to give it a config. We're gonna show it to, I'm gonna show it to you later. But you create your config and then you apply the new application adapter and the new config to create a window. So in our case, we create the MyGDX game using the config we've declared up here. It's quite simple, at least for now. We declare our variables. I think I don't need to explain to you how that works. We create what we call the sprite batch, and we're going to create a texture image. The sprite batch is basically the drawing hand of your application. So you're going to use a batch to draw everything. Now, 2D is a little bit weird when you first use it, because you kind of understand that it's drawing everything all the time. I'm going to show an example of that later. But yeah, the batch is what you're going to use to draw everything. You're going to need to control that batch by starting it and ending it. In our case, it doesn't really matter when we start it, when we end it. We do need to do the drawing between those two. But if I were to use multiple batch for different reasons, because I need transparency, because I used to need use some shaders, stuff like that, I could be using multiple batch. Right now, I only have one batch, and I'm just drawing an image. I'm also cleaning the screen. So what do we have here? We have a create, we have a render, and we have a dispose. When we create the application, we call the create. So far, so good. In our case, we say, okay, I want a new sprite batch, and I want to create an image using the texture badlogic.jpg. That's simple. Then you go in the render queue. The render queue is a little bit more complex. The render queue is going to be called usually 60 times per second. Okay, so actually we're going to need to draw our image 60 times per second, more or less. Now there are optimizations, so you don't need to draw everything all the time. But in our case, we're going to clean the screen. We're going to start our batch. We're going to draw an image, and we're going to stop the batch. Okay, so it's the same thing as we've seen before. We just create that thing. We have an image. Right now, I have a black background because I didn't change the color of the background. But it's that simple, not that interesting. When it starts to be interesting is when we actually start to move stuff around. In our case, right now we have the application configuration where we're going to declare a width, an height, a foreground FPS. I'm actually going to cancel this one. Foreground FPS and a background FPS. So as you can guess, this is going to be the width of my screen. This is going to be the height of my screen. This is going to be the FPS of my application. And this is going to be the FPS of my application when it's run in the background. Currently, I'm putting it at 0. You're going to see what it's going to do. And I create my application. So it's more or less the same application. I create my batch. I create my image. I still do my clearing. I actually going to change the title of my screen to my currently frame per second. As you can see, there's a lot of static stuff. In our case, this is for OpenGL. So this is an OpenGL function. If you go inside, you can actually see all the code. You see, oh, this is GL20. But what is GL20? Well, it's actually an interface wrapping all of the methods of OpenGL. Okay. So you have quite a lot of static stuff. You're going to see a couple of things. Just understand that, there's a lot of information that you can access using the gdx.something. So for instance, right next to it, we have the GDX graphics at set title. I can actually use graphics to get a lot of info. Oh, am I able to get that keyboard? Yeah, like the display screen. So I can see my display mode. I can see the density of my pixels. I can get most of my information about my page using that. So in our case, yeah, we're going to show the get frame per second. We're going to start our batch and we're going to, oh, that's not the right one. We're going to increase a value with a ++ every time we call the render. we're going to draw an image, which is basically my image that we're going to put at the position I've declared earlier. And we're going to stop the batch. So what we're going to have here, it's quite simple. I'm going to have a little image that moves. So far, so good. It's a little bit more interesting, but it's still somewhat easy. Now let me show you what happened if I do not clean my screen. If I do not clean my screen every time I draw on it, I'm going to keep what was there earlier. So if I start that again, you can see that I actually keep some part of the information right here because I don't do a cleaning on my screen. So each and every time I'm drawing here, I'm not erasing what was behind. I'm not creating a new image. I'm adding a new image on top of it. It's a little bit long to explain how it goes in the computer, but you just need to understand that if you don't clean it, you're going to have some stuff like that. So this is why you do the cleaning. In our case, as you could see, it was slowly moving. I don't know if you can really have a feeling of how not smooth it is, considering the video. But right now we're kind of at 60 FPS, but we have a problem because we're drawing an image every time we call the render. The problem is the computer is not perfect. It's not going to call the render queue each and every time at the same moment. Even though it's trying to, if I were to show it to you, the delta time or the time between each drawings, it's not that consistent. So hopefully I'm going to be able to show it to you. If you can see properly. Okay, let's stop that. So as you can see, it's more or less 0.16, but it's moving around. It's going to 13. It's going to 17. Can I get one? It's going to 15. It's going to 17. So it's moving everywhere. So even though I'm going to have 60 frames in a second, I'm not having them perfectly ordered. So to counter that, I need to consider my delta time. So the proper way to actually move an image would not be to add a value ++ on my render queue. It would be to say, okay, so you're going to modify your value X, but you're going to take in consideration my delta time. So in my case, I'm going to say, okay, add 100 multiplied by my delta time. And in that case, it's going to be more fluid. Even though, as I said, you're not really going to be able to see it. Just download it and see it for your own. But yeah, now my image is properly moving. And no matter the frame rate, it's going to move at the same time. So if I were to change to 60 for 10, this is how I change my FPS, by the way. It's going to be super weird looking, but it's moving at the same speed. It wouldn't be the case if I were to just go with the value ++, because as I said, this is the render queue. It's called 10 times per second now. It used to be called 60 times per second. So it's going to be way slower than it was before, like actually 6 times slower. So when you create an application, you need to consider the fact that you must consider the delta time to properly draw on the screen. You also need to consider the fact that some device, like Android's phone, will cap their frame rate at 30. And some devices are actually going to cap them at 120. So when you create a game, you need to always consider the delta time. This is why some games that have been poorly coded can actually change the speed of the game depending on the frame rate, because they didn't consider their delta time. They just said, oh yeah, I'm expecting 60 frames per second. I'm going to use my render queue as if I'm going to get 60 frames per second and everything's going to be good. It's not. By the way, the background FPS, just so I can show it to you quickly, is how quickly the game is going to run in the background. So if I were to actually click elsewhere, you can see it actually moves faster. If I click back here, it moves slower because this is my foreground FPS and this is my background FPS. If you put it at 0, it's always going to try to go to the maximum available value. If you put it to -1, then it's actually going to stop. So if I'm going to put that back here, move that here. When I click here, it moves. When I click there, it stops. Okay? So just so you can understand the concept of foreground and background frame per second. Is that clear for everyone? Gonna hope so, because we're gonna move. If you have any questions, just ask them when writing. Like you have to use get delta time everywhere. You actually do. Otherwise, it's gonna get clunky. So you're supposed to use the get delta time everywhere. You usually declare it somewhere else so you can, access it easier. You don't need to call it all the time. But yeah, we're going to go for adding sprites. Okay, I still need to move quickly. Oh God, I don't have that much time. We're going to skip a lot of stuff in 3D. I'm sorry about that. But yeah, I do believe 2D is easier to explain. And anyway, we're going to declare our application. We're just going to get config with int, and we're going to create an animation. So basically, animations in 2D are a couple of images put together, one after the other. Currently, we're going to use a little something called jump atlas. Okay, so this is what we're going to use to create an image. This is not ordered. This is not anything, but this is a couple of images that I put all together and described in an atlas. So the concept is because it is easier for the computer to load a large image and then cut it, we usually create a couple of large atlases so we can optimize the image loading process. So you usually have a couple of these, can have more than one animation in an atlas. In our case, we only have one. But yeah, we're gonna load that atlas. So as you can see, I create my batch. I'm always gonna need my batch. Can I use it without an atlas by just a calculation? Yes, you can. It's not recommended, but you can do it. And there's actually more than one way to create an animation. So I'm going to show you one way to do it, the way I use it the most. But you actually have stuff like spine that are going to create like some sort of 3D model that then it's going to draw and use some physics on it. There's a lot of ways to do the same thing. But yeah, you don't necessarily need an atlas. I'm just showing it to you because it's explaining a lot of stuff about 2D. So yeah, I'm loading my atlas. I have my atlas right here. I have my jump atlas that I've shown to you in my asset folder. I'm going to need to create an array of atlas regions. So basically, I'm telling him, all right, load the atlas. You're going to have a couple of regions in that atlas. If we check that again, that's a region, that's a region, that's a region. So it says, okay, cut everything up into little textures so I can actually use them for my animation. We're going to say, okay, my series of texture region is now built using the atlas region. I'm going to give it a speed saying, okay, how many seconds should you stay on the same frame? Because you actually have a couple of frames per second, as we've seen. And depending on the speed of my animation, I can go faster or slower. We're going to show you the example. It's going to be way more clear. Okay. So just say you have current animation. Okay. This is my animation. This is the region you're going to use. This is my speed. And you can set a loop type. Well, you can say put the play mode. Sorry. In our case, it's going to be loop. So you can see the animation again and again and again. I go back to my render queue. I say, okay, clean that thing. I'm going to need to change my state time, which is basically going to tell me, okay, I'm supposed to be at this step in the animation. I'm going to be using my delta time again, because as I said, depending how fast is my screen or anything, I want my animation to go the same way. So if I have more frame, I don't want my animation to be faster. If I have less frame, I don't want my animation to be slower. I want the animation to be roughly always the same time. And I say, okay, my current frame is going to be equal to my current animation dot get keyframe depending on my state time. So basically, I'm telling him, okay, I have an animation. I'm currently at this point in my state. What is going to be the frame I need to draw at this moment? I start my batch. I say, okay, I have my frame. This is the size of my frame. I want to put it position 0, 0. Let get region width. So get the width of that image, get the height of that region. And then if you just start that, we're going to see exactly this. So you have my little bunny and he's jumping. Okay, he's jumping a little bit fast. I'm actually going to slow that down so you can properly see it frame by frame. Yeah. So as you can see, I have my little bunny and he's slowly jumping and my animation is looping. Okay, so this is most of the time how you're going to do animation. You have a couple of images, you put them together in Atlas. You say, okay, this is my first image, second one, second one, second one. How do you define as by priority? By drawing order. Exactly. So that's actually something I've skipped. When you draw, you actually are drawing an image. So if I were to draw a couple of them and say, okay, I want to draw this one at 0. Oh, that's going to be better. I'm going to want to draw this one at 100 and I'm going to draw this at 200. I'm actually going to draw the first one. Then I'm going to draw the other one on top of the first one. Then I'm going to draw the third one on top of the other one. So the drawing order is actually quite important. You can also set a couple of things using the x-axis, z-axis. But yeah, this is going to be my drawing priority. I'm drawing stuff on a board. So you need to think about somebody who's drawing something, then he's drawing something on top of it, then he's drawing something on top of it. So you would actually be drawing your background first, then you would be drawing your ground or something like that, and then you would be drawing your characters. And because of the way the computer is going to do it, he's going to draw the background one shot, he's going to draw something else, and then he's going to draw something else. Current frame is an instance variable instead of local. Is it because of performance? No, this is definitely not for performance. This is just for, you know, for testing. In that case, though, you're talking about which one? Current frame. Yeah, current frame. Yeah, you want to create as few objects as possible and have as few references as possible. So you don't want to have any memory leak. So yeah, you'd be better off creating it outside. So you're not creating a ton of object. So the garbage collector doesn't have too much work to do. So yeah, we're going to start. We're going to draw them and we're going to see how it goes. So as you can see, I'm drawing the first one, then I'm drawing the second one, then I'm drawing the third one, and they're all on top of each other. If I were to do it the other way around, it would be the exact same thing, but the other way around, because I would be drawing the one on the right as first. It would actually show this way. Okay, so yeah, the drawing priority, the first one that is drawn is going to be drawn on the background. Because as I said, you need to think about it as a canvas. I'm drawing something, then I'm drawing something else. Okay. That's going to be that, Shan. I've put some resources available here. Texture Packer, which is what I use for most of the texture packing. Basically, it's that little tool. There's also a version available in LibGDX. If I were to show it to you, I think I have the resources here, so you can actually play with them. Let me just drag and drop them. Where is the application? Sorry, I have way too many things here. So all you need to do is drag and drop. Nah, I'm not gonna be able, sorry. It's a little bit, I'm gonna need to do it on the other screen. So as you can see, I've loaded all of my textures. Oh, can I? Yeah. All of my texture on a canvas. I can set up a couple of things. In our case, it's gonna be easier if we actually just tell him, don't rotate, don't do anything, advanced settings. The way I created it, just forced squared. And where is rotation? Allow rotation. And you actually need to increase the size. So that's a little bit complex. As I said, I don't have that much time, so I'm going to need to keep on moving. But this is more or less how you create a texture atlas. You just give him a couple of images. You declare that's number 1, that's number 2, that's number 3. He's going to put it in a way he feels it's optimized. He's going to create a sheet where you have all of your image, and then you're going to be able to use it in an animation. Okay. Let's go to the next one, interface. That's also something I'm going to show to you quickly. When you create an interface in a 2D game, you need to create a stage where you're going to be able to set buttons and stuff like that. So even though your game is 2D, you're not drawing your buttons and everything the same way you're drawing your sprites, your background, and stuff like that. You actually need a stage to put all of your buttons. In our case, we're going to create a text button, and we're going to create a text button style so we can actually say how we should draw that button. So we create our stage. We set the input processor. So when you put inputs in your game, you need to actually tell the game, by the way, listen to this or listen to that. In our case, we say, okay, listen to the stage. Later, well, maybe not in this presentation, but later you're going to need to have more than one input processor. There's an object for that. I think it's like multi-input processor, something like that, multi-input frame. Let me just check that quickly. Input, you have a couple of input listener. Sorry, I should have checked that before. Okay, so you can actually have a multi-input processor that you can add, because you can only add one input. So don't be surprised if you decide to add your stage and then you add your controller or your keyboard or something like that, and it stopped working. You need to set only one input processor, and that input processor can contain multiple inputs. Okay. We're going to create a font using bitmap font. I'm going to skip that. We're going to create a skin, which is basically where we're going to put all of the information about, oh, this is how I should draw a button. This is what happens when I go over my button. This is how when I click on my button. This is what happens when my button is checked. You can actually personalize all of that with an interface that's available. I think I forgot to put it here. I'm going to put that back after the presentation. But yeah, we're just going to show it to you quickly so you can understand. Going to go the interface. So in my case, I have a button now. It's called button 1. When I click on it, turn red. When I release, it's blue. When I click again, it goes red. When I release, it's black again. So what's happening here? I declared a skin. I created my own skin. I said, I want a style for my buttons. I told him, okay, by the way, the font is my bitmap font that I declared right here. And for the regions, for how I'm going to draw everything, I told him, okay, create a drawable, which is another type of texture that is used for buttons and stuff like that. I say, use bad logic for my up option, use bad logic 2 for my down option, and use bad logic 3 for my checked option. If we go check in our assets, we have bad logic 2, and bad logic 3. So you don't need to set the image every time. You just need to tell him, okay, by the way, this is how you should draw a button. This is my button style. So if I want to create a couple of buttons, I can actually set them beforehand and then just say, oh, by the way, add a button. Okay, it is quite simple. As I said, it's too bad I don't have the links here because you have editors and stuff like that. Right now, all you need to do is create your file using that editor, telling him, okay, this is what should happen at this moment. This is what happened at this moment. It's going to export you a file. Then you just load that file into the game and then say, okay, this is how I draw my interface. All right, I'm moving quickly. Where is the skin object being used? It's not actually, sorry. It used to be, they used to put the text button style in the skin because yeah, you can actually create a skin and then apply the skin. In my case, I only use the text button style. So my text button style would be in the skin object. Right now, I don't use it just so I can show it to you on the very, very basic level. That is a good question indeed. So yeah, and then I add on my stage, as I was saying, my stage where I'm going to put all my button, my new button, and this is how it goes. You also need to draw the stage. So this is something you need to remember, and you can decide when you draw the stage. So it is very important in our case to draw the stage at the latest moment. So the interface is going to be on top of everything. But let's say you want the background to go on top of the interface for some reason, because you have a cinematic or you have something else. You could actually decide to say, okay, draw stage at this moment or this moment, so you can create your canvas properly. We're going to skip gravity and control because I think I'm not going to have enough time to talk about 3D if I don't. Where did I put game logic? Not in the render. You actually do. So you put all of the game logic. Well, depends. You're going to create objects, but you're going to render them. It's I don't like the term render because, as I said, it's not only the rendering. It's also going to be the logic. Usually what you do, you create two methods in your render method. One that's going to be actual rendering, telling him, okay, you need to draw this, you need to draw that. And another one that's going to be logic, where you're going to use your delta time to properly calculate everything. I have an example of a game. I hope I'm going to have some time. I'm really, really short. Sorry about that. I'm going to be able to book question later. I think I'm going to need to move on. How do you handle collision? Do you have to define rectangles? That's exactly where we're going. So I'm going to answer that one. As I say, I have two examples for gravity. Oh yeah, they're way too slow. I was expecting an hour. 45 minutes is going to be, it's going to be super short. Anyway, to gravity. So I'm going to show it to you quickly, just so I can run. I'm going to save interface. So right now I have my little thing. As you can see, the image and the box is not the same item. That's all I'm going to talk to you about. This is the example for box 2D, and there's a lot of examples. Right now, the biggest difference is I'm declaring a world. I'm declaring a body definition. I'm going to join my body definition with my item. As I said, all of the code is available on the GitHub. There's a lot of stuff to show. As I say, I'm sorry, there's just too much to show. So basically, yeah, just understand that the image is not going to be the physics, but you can link the two by moving stuff around. In our case, when we're doing the rendering, just so I can quickly show it to you, we're going to draw everything based on the position of my cube. Where is it? Where is it? Run resolution batch sprite get 8. Now I'm going to move my sprite. Okay, so what I'm doing, I'm setting the position of my sprite based on my body. Okay, so just understand, if anything, that you move your body and then you set up your sprite, because they're not the same object. So physics is one thing, visuals is another thing. So sorry about that. I'm going to need to cut it short because I do want to talk a little bit about 3D. Where's are my slides? They're going to be right here. David, I'm so short on time. So JMonkey engine is going to be for 3D. It's free and open source again. It started in 2003. It's 17 years old. It's super old. It was started by Mark Powell as a little side project. It is quite impressive. I'm going to be fully honest with you. I tried to reunite with JMonkey engine. It's hard for me to say. The community is still alive. But if you really want to create a 3D game and you don't care about Java, I would not recommend JMonkey. As much as I can recommend LibGDX, JMonkey is a little bit too clunky and it's a little bit too old. So if you just want to understand how a 3D game works, this is probably the best one because it's very, very low level and you need to do a lot of stuff and take control of a lot of elements. But I feel bad saying that, but I really try to reunite with JMonkey. But yeah, anyway, if you want to install it, it's quite simple. It's running on NetBeans. It has its own little SD key. Let's go to, it's going to be, I think I have it here. No, that's the store. Sorry. That's going to be the starting. If I go here, yeah. So get started. You can get the libraries or you can get the SD key. In the case of the SD key, I should have it here. So you just have an installer. It's quite simple. I'm not going to install it right now, but you can start it here. And it's going to look a little bit something like that. So it's based on NetBeans. There's a lot of options here. You can actually control your objects. Is that one going to work? I think that one not. Okay, we're going to need to show the scene perhaps. Was doing some testing, as I said. Okay, let's go directly to the code. Okay, sorry about that. Yeah. So you actually have a lot of tutorials available. I've put them in the slides. You also have a store now, which is something that's like 3 years old, but for me, it's quite new because I haven't been playing with JMonkey since a while. You have a lot of examples here, and they're all available on GitHub. Right now, what I'm going to show to you, 5 more minutes if you like. I'm going to take them. You have a couple of, in our case, 3D models. So you can actually download the 3D models. As I said, it's a little bit clunky. Right now, it's supposed to load. It's super slow. 3D models, if I can click again. Okay, now it works. 5 minutes. Okay. So it's going to load everything. We're going to have a spider example. I might as well show, yeah, that's it. So you have a couple examples. Right now, we're going to check the SpiderX 3D model. Example JMonkey, that one's also available. JMonkey is quite simple. You create an application, create new, start, blah, blah, blah. Let me just start quickly about the main so I can just show to you that it works and it's actually quite interesting. So I'm going to start this one. So yeah, right now we have a really, really creepy spider. Happy Halloween, everyone. And how do you create that spider? You currently have a 3D model that you can look in the assets. That's in SpiderX. You have a couple of texture. To create 3D objects, you actually need to import them. You're going to turn them into G3O, which is JMonkey 3 objects. If I show it to you, yeah, you create nodes. You need to, oh my God, there's just too much for me to show to you in such a short time frame. So yeah, basically you create object, you create nodes. You have examples there. If you have any question, you can message me. I'm going to be able to answer them. I'm truly sorry. It's 5 minutes. I might as well not start explaining anything. Otherwise, I'm just going to get you guys lost. Just know that, yeah, it's available. There's a store right there where you can load a lot of stuff. How do I contact you? I'm available on LinkedIn. I'm going to be able on email on simonbedardprog@gmail.com. I'm going to actually put it in the slides. That would be a good idea. And yeah, I'm going to put that available right away. Just to make a little recap, sorry about that. I'm not going to be able to present the 3D. You can code video games in Java. I think I've showed it to you. There's a lot of stuff to know, but it's absolutely fascinating, in my honest opinion. 2D is easier than 3D, but it's one less dimension. If you're actually passionate by how 3D works, because it is a fascinating subject, actually go and dig JMonkey. For all of its faults, it's still fascinating to see how it deals with 3D object, with light, with shaders, with stuff like that. And it's because it is so low level, you actually need to do everything. So you need to understand everything. So you learn everything, okay? If you are interested by game development, I actually have a game jam presentation tomorrow. This one is way shorter. There's not as much code to show, so I should be able to, have it done on time. It's going to be tomorrow at 14, and we're going to talk about game jams, which are events where you create video games in 48 hours. So if you want to practice and you actually want to, use your skills and meet with people, even though you're not going to meet directly nowadays, come tomorrow. We're going to talk about game jams. All of the games I've shown to you for LibGDX, most of them were created during game jams. So that absolute monstrous amount of games were created during game jam. So if you just want to create your first tiny game, what I would recommend, start reading about LibGDX, start to create your first project, start to understand how the render loops work, try to render a couple of objects, get frustrated because it is quite frustrated at first, understand how camera works. We didn't have time to talk about camera, but they're very, very, very important. If nothing is showing on the screen, just a little tips, it's because of cameras, okay? Just remember that. And once you feel ready, actually join your first game jam. Because they organize a couple, I think they organize once a month. So yeah, sorry if it was a bit messy. I kind of realized last minute that it was a little bit too big of a presentation. I hope you guys still enjoyed. And yeah, if you have any question, I'm going to be available here. Visit Java again. Now using Godot. Yeah, Godot is pretty darn great. Godot is actually probably better if you want to do 3D, but I do believe if you want to use 2D, you're going to be better with LibGDX. LibGDX is absolutely beautiful. Well, thanks to you, everyone. Can you start at the beginning? Like with everything? Well, happy to see the idea of making a bunny animation jump now excites me. Oh yeah, I might as well show that to you. So this is my own little project. It's a pet project, but just to show you what a guy with very, very small amount of time every week is able to create. This is, oh wait, it's a little bit too big for the screen. I guess there's a problem with the size, but yeah, this is actually a little game I'm working on with a friend, and this is all LibGDX. So this is Parallax. The Parallax library is actually available on my GitHub. It's a bit messy, but it works. And yeah, the character can jump and you can go over to stuff. And right now it's a very early stage, but yeah, this is the kind of stuff you're able to do. All right, well, happy to see you enjoyed it. Bye-bye, everyone.